What's up, everybody? I'm Matt Gary, and in this episode of Coding with the Force, we're going to go over the Dependency Inversion Principle. We're going to figure out what it is, why it's important, and how to actually implement it in both Apex and JavaScript. All right, everybody. So today, in the sixth and final episode in the Solid Design Principle tutorial series, we are going to go over the Dependency Inversion Principle. The D in Solid, S-O-L-I-D, stands for Dependency Inversion Principle. And this is my favorite principle, and it's a principle that if you've watched all the rest of the videos in this series, we've already implemented several times. It's also the only principle, I would say, that maybe has a definition that's a little bit broader than it ought to be. But nonetheless, this is my favorite principle. It's an extremely powerful principle, and it makes it so you can create incredibly flexible code bases around code that changes extremely frequently, right? So let's first go over what the dependency inversion principle is and why it's important. And then we're going to, just like all the rest of them, do an Apex example and a JavaScript example. So let's go over it. In most definitions that you'll find for the dependency inversion principle, it will say something along the lines of, it tells us that the most flexible systems, the dependency inversion principle tells us that the most flexible systems are those in which source code dependencies refer to abstractions, not to concretions. And if you take that at face value, you think, that's not really possible. And technically speaking, you're not entirely wrong. It's impossible to get away from concretions, concrete class implementations, like the string class, for instance, or the integer class. If you didn't know, those all have classes, and you can't get away from using those. Those are system languages or system parts of the Apex language that just come kind of pre-baked for you, right? And that's okay. You can use those kind of things. You can use those concrete implementations because you know that they're almost never going to change. You can basically count on those things like the string class and those system defined classes to never change. But if you take the dependency inversion principle at face value, it breaks that rule, right? You are, by definition, by using those string or integer or whatever classes that kind of come pre-baked in Apex and plenty of other development languages, you're using their concrete implementations, not an abstraction of them. And you don't want to go out of your way to abstract the string class or something, right? Really, what we care about are volatile or constantly changing classes. And if you've done development for very long, you know what those things are. They're almost always the classes that are related to business logic. So like we have in this example in front of me with the opportunity service or opportunity calculator service, which already implements the dependency inversion principle and that we built together in a prior episode. This is something that might change a lot. In some orgs, you use opportunities, and you might want to calculate the value of those opportunities based on some business logic. And that opportunity calculation might change depending on who you are in the system. Who knows? And if you had a concrete implementation of your opportunity calculator that houses a bunch of business logic, that is business logic is almost always the thing that changes the most in your system, then at that point you have broken the dependency inversion principle, because that business logic, that service class logic, that logic that you know is going to change for sure over time, That's what we're talking about, and that's what you want to target when you're implementing the dependency inversion principle. Anything you think as a developer could change and likely will change is what you're supposed to and ideally will target with the dependency inversion principle. And so now we know what the dependency inversion principle is and kind of what we're trying to get out of it. We're trying to get an abstract implementation of a class instead of a concrete implementation of that business logic referenced throughout our code base, which might seem confusing again, but when we build this together, it's going to be a little less confusing. As far as why it's super useful, it's because you can build things once and not have to rebuild them over and over again. And it also makes it so that your code isn't as fragile, which, you know, we'll go over a little bit more when we're writing the code together. But if you, say for instance, had business logic that you'd written for this opportunity calculator, and the first time that you wrote that business logic, it only needed to run one way for everybody, right? But then a month down the line, it needs to run a totally different way for another person or another group of people. And you've just got this, you know, concrete implementation of your code that works for this one situation. And maybe that code is used in a controller, like it's called by a controller directly, and that controller depends on that concrete business logic for that singular use case, right? Well, if that's the situation, then not only is it going to be challenging for you to go in and change all of your code, it will probably become very ugly, things that we've talked about in other videos in this series, and we'll see more when we do the example. The code will become bigger and uglier in that one class and harder to maintain over time. And also your controller that, you know, interfaces your code with your Lightning Web Component, and potentially your Lightning Web Component as well, will become more and more rigid as time goes on, where one little small tweak to your code starts to break everything, right? And we've all been there, I think, if you've been in development for more than, 6 months probably. So the dependency inversion principle kind of removes those problems. It makes it so your code isn't rigid and prone to failure just because you updated one small thing. And it also makes it so that your code is much more flexible and can adapt to those incoming changes easier as time goes on, instead of it being more and more of a pain as time goes on. Also, this rule kind of holds all the other ones together in a lot of ways. If you don't implement this, it's kind of hard to implement all the rest of the rules in practice. So it's extremely important that you understand how this works and how to implement it, because without it, you can implement the other rules, but you're not going to have the same level of success in implementing them. So, all right, hopefully all that kind of made sense, but if it didn't, don't worry, because we're gonna write some Apex now to make it all make sense. So let's do that together. Okay, so in front of us we have a case closure service class. And this case closure service class basically takes a list of cases and determines whether or not they should close, and then either actually closes them or rejects closing those cases. And this is currently called by an Apex controller that a Lightning Web Component works with. And the Lightning Web Component, on a button click, will call this close case method in the controller, which then calls out to that case closure service class we were just looking at, passes it a list of cases, and does its thing, right? It determines whether or not it should close. Now, this is great and wonderful right now. It's small, it's compact, it's very simple. But the problem with this is that this is business logic. And this is maybe just the first implementation of this business logic. And this is how it goes sometimes. The first time that you implement some code in an environment, it looks like this. You have this concrete setup, but as your implementation evolves over time and more people start using Service Cloud and closing cases in different ways, this becomes more and more of a bad situation that you've got yourself into because you have all this concrete code in here. Now, say for instance, right now, every single case, if it's got the status of resolved or tacos, it should actually close. Otherwise, it should reject. Fine. But what happens, theoretically, say, if a new type of case was created? Maybe all of a sudden, originally you were taking cases for order complaints, right? But now there's a case that comes in for like order delivery complaints. So there wasn't a problem with the actual order, but there was a problem with the delivery mechanism for that order. You're getting some new piece of furniture and it takes way too long to get there, or the delivery crew did a horrible job. Who knows, right? I don't know. But you've got two different types of cases now and two different types of situations. And the business comes to you and says, hey, I know that historically we were making it so that every case that has a status of resolved or tacos was closed, but in this new delivery complaint case type, we wanted to change. We wanted so that if it's a delivery case type, it should only close if it has a status of delivered successfully or something along those lines, right? Or just delivered, who knows? And so you're faced with a situation, right? Do you continue to update this code, or do you use the dependency inversion principle to make it maybe a little cleaner? And what I mean by that is, say this was actually the situation. I would have to now update this code and say if cs.recordtype dot name equals we'll say delivery, and cs.status equals delivered, then cases to close dot add, and then I'd have to update this statement here to say, else if cs dot record type dot name equals order, maybe, and status equals status resolved or tacos, then close the case. Otherwise, reject them, right? Now, what you're going to find, unless you're unfortunate and your org doesn't grow, which it almost always will, even if you're a small company right now, chances are high your small company will grow and grow. I hope, anyway. And this will become worse and worse. You'll get another record type for a different type of case, or you'll get a whole new business unit that comes on, and that whole new business unit needs an entirely different process, but they're working in the same org, right? And you have to make this choice. Do I make this code for this one singular implementation more and more complex and more rigid, or do I find another way to deal with this situation? And honestly, I think because people don't understand what the dependency inversion principle is and how to leverage it, this actually ends up creating, ends up having people choose to have a multi-org situation when in fact all they needed to do was architect their code a little better and leverage the dependency inversion principle. I see this a lot out there. There's like a new business unit, so instead of onboarding them because their processes clash too much, they just like throw them in a new org. Why? Just figure out how to code. Anyway, let's figure out how we can get rid of this problem. Because what this ultimately leads to when you're, you start shoving tons and tons of logic for tons of different things in the same class is a really fragile class. And especially when there's two different business units, what you end up having is, this problem with dependency, right? Now, if you put all of business unit A and B's logic in the same class, well then anytime you update this class, you have to, if you're business unit A or B, you have to tell the other one, hey, I'm updating this class just so you know, I might break something, so you should test it. And then everybody, business unit A wastes their points testing things for their sprint cycle, or business unit B or whatever else. And it becomes a problem. And you kind of get in this weird gridlock where you can't ever change anything and everybody's always upset. So now that we have a general idea of why this is such an important concept to understand and implement in your code, let's figure out how to actually do it. All right, so first things first. Remember, the dependency inversion principle tells us that we should refer to abstractions, not concretions. So we're violating that principle here right now because this case closure service, when we call it, is a concrete implementation of a class or of a business process or whatever. And we're going to see how we can completely annihilate this and make it so that you never have to do this again. And so what we're going to do is a couple things. The first thing that we're going to do is create an interface. So we're going to create an interface, and we'll call it case closure service interface or something. I don't know. And if you have no idea what an interface is, or you're completely uncomfortable with the concept, I'm going to link a video up above to a tutorial that goes over all there is you need to know about interfaces that I made myself. So I hope it's very useful and doesn't confuse you. And then come back here and we'll keep going. But you do need to know what an interface is. I'll go over a little bit of it, but that tutorial explains it much more in depth. Whew. All right, so we've got our case closure interface here, and we need to actually take this determine if case should close method and create a method stub in this interface for it. So now this interface, case closure service interface, has this determine if case should close method stub, which is great. If you look at this service, you can see it, even though we have 3 methods, we only have one that's public. And it's the only one that's going to, at least currently, be being called by a controller or a batch class or whatever. So it's the only one that we need in the interface. The rest of them can be implemented individually in their concrete implementations, as we'll see here in a second. So the next thing that we'll do is we have this these 2 different record types, order and delivery. So what we're going to do is actually create the concrete implementations for each of those. So we will create yet another new Apex class, and we'll call it case closure service delivery, if I can spell, delivery impl. Impl stands for implementation. This is extremely common. You'll see this a lot of places, especially outside the world of Salesforce. So we've got this concrete implementation class called case closure service delivery impl. And we need to make sure that it implements our case closure service interface, because this interface is the method in which we're going to actually abstract everything here in just a second, which we'll see. And so we're going to get that method stub and drop it in here. Make it an actual method. Make it a public one. And then we're going to grab our code here. Drop it in here. Get rid of this block. And and add these in here. And, you know, this is also great because what if for delivery methods, I didn't even, talk about this, but what if for delivery record types, I wanted the reject case closure to be redo case or something, and I wanted the close to be closed delivered instead of regular closed, right? Now I can do that super easy, and as we'll see in a minute, I'm not getting in the way of this code, and it's not making this code any bigger either, right? So, okay, so I've got this case closure service delivery impl that works for this delivery record type, if I can think of words. And because it's only going to work for that delivery record type, I don't even need to check for that record type now, which makes my code at least marginally faster. And the next thing that we'll do is create the implementation for the order type. So again, we will create just another Apex class. We'll call it, again, case closure service order impl. And I'm just gonna basically grab this same stuff, make sure that it implements again our interface, and drop this in here and make the couple of changes I need to make. So I need to change this to resolved or tacos. All right. This is the order or impl. Drop those in here, and then I need to grab my old rejected. Oh no, I'm right. Rejected and closed. I guess I can just delete this. And that'll do it. So I've got these two concrete implementations, and now I've got so I've got one class for the order record type, I've got one class for the delivery record type, or this could be for different business units, which is even more powerful. It could be for a concrete implementation for business unit A and business unit B. And now I need kind of a middleman to really tie this together and make it so that nothing depends on these concrete abstractions, or sorry, these concrete implementations anymore. So what we're going to do is create yet one more class, and we're going to call it case close service, and I'm only calling it case close service instead of case. You know what? Actually, I don't need to do this. I'll just take this case closure service I have here and repurpose it, because this is what I would normally name this class, case closure service. So now I've got this case closure service, and all it has is a static method called determine if case should close, and we need to implement something called the factory pattern to make this work. If you don't know what the factory pattern is, please, I got a video for that one too. Check it out. You won't be lost, and you'll have a much better understanding of what's about to happen. So check it out. Anyway, so what we're going to do is we're going to create a private static map. And to keep it simple, I'm just going to do a string and a type. And we'll call this case closure service by record type. And we'll set it equal again to a new map string type. And we'll actually build the map here. So we'll say if the record type is order, then I want to map it to case closure service order implementation. And if the record type is delivery, I want to map it to case closure service delivery class. Cool. So we've got this little map that says, you know, if I send in an order, the word order, or I send in the word delivery, then I'm going to get returned to me one of those two classes that I just made. And down here, what we're going to do is use that case closure service interface to initialize these classes, and by doing that, basically we've decoupled everything, right? We've completely decoupled the controller from these other two classes, and we now are going to be using an abstraction instead of a concrete implementation. So we'll say case closure service equals case closure service interface, and say case closure service by record type dot get, and we need to actually pass in the record type name to this method, so we'll say string record type name, and we'll say record type name dot new instance. And so what this big old long line of code does is we are now initializing one of these two classes through the use of their interface, because the way the interfaces work is that now once you make something implement an interface, they inherit that type. I don't want to use the word inherit, but they can be of that type, and also because they use that interface, they are bound and must implement these methods. So as we are going to see, because they must implement those methods in the interface, we can say case closure service dot determine if case should close and pass it cases. And now we have this completely abstract, beautiful thing where you have, you know, code for record type A in one group, or in one class, and code for record type B in another class, and your controller now calls, what does it complain about? Oh, I need to pass it a record type name. And your controller now calls a very abstract class, right? So there's no concrete implementations here anymore. As you can see by what I'm calling now, I'm literally calling one line of code in this controller. There's no direct call to either of the concrete implementations in this class. We are calling them at runtime based on, you know, what record type we're working with. I feel like my face was really weird there for a second. Whatever. Right? And you can kind of see that, right? And so now we're calling everything through this interface. It's very abstract. If we need a new thing, if we need a new concrete implementation, easy to implement. We create the new record type potentially. We create a new implementation class, and we, you know, implement it here. We don't have to change the controller. We don't have to change virtually anything aside from we create another one of these implementation classes. We reference it here in the map, and that's it. And if we need to update this case closure service for, orders, then we can do that. And when we do that, we're not impacting the delivery version, right? Nothing changes there. We don't need to contact the people that use delivery and ask them to test things. We don't even have to care about testing them ourselves, because we didn't change this code. We don't have to change this code, and we never will have to change this code when we're updating things for orders, right? There's an enormous amount of power and flexibility in that that just should not be overlooked. And let's just run this. So I am going to just do something real simple to prove that this works. And we're going to do a debug that says calling order class. And we'll do another debug in here that says calling service class, right? I'm going to try to save this, and I got about a 50% win rate with these. I have a feeling, yeah, I'm going to have to save these in order. So we'll say save the interface first. You always want to save the interface first. Then we'll save the implementation classes. Maybe invalid interface case closure. Oh, it is indeed not a real interface. Oh, so that's good. So we'll save both of these. Sorry if that was very confusing. It should have used the interface that we actually made, not whatever fake thing auto-completed there. And I will save this one, which completed successfully. And last but not least, I'll save this controller. And what I'm going to do, just to test this and keep it super simple, is I'm going to open up my anonymous Apex window here in IntelliJ. And I'm just going to drop this in and send in a case with a new case that has nothing in it. And just send in the record type name of order to see if we actually run the order class, right? There's probably going to be some things that fail. But you can see it did indeed call the case closure service order impl, which is cool, right? And it says down here, as you can see, despite all my code failing because I'm not actually giving it a real case, that it did call the order class. And if I went to the service and I passed it delivery instead of order, we should see that it calls the, I put calling service class in here? Okay. I put calling service class, which should have been calling delivery class, but you can see that it did change its debug to calling service class, and we called the right class. So even though the code failed because I passed it a case with literally nothing in it, which is not helpful, we did get what we wanted, right? At runtime, it determined this is a case of type delivery. We need to implement this class, and it worked, despite, you know, this all being very abstract. All right. I think that does it for the Apex stuff. As you can see, there's a lot of power and flexibility in this, and the more that your org grows and evolves and kind of spreads apart with different record types or business units or whatever else, the more and more utility you get out of dependency inversion. And it can really save you from a lot of things, like you can get a lot of complaints from business units, from dependencies from business unit A and B, that will lead to you purchasing things like a brand new production org for no reason and separating things out, when if you just took the time to fix the code, you wouldn't have to waste all that money. But you know, whatever. And so now let's go check out how to do this in JavaScript, right? It's a pretty similar concept, and in fact, we've actually already implemented this previously when we did the single responsibility principle. If you maybe remember, we had this whole setup. Actually, I kind of want to save your time and maybe mine, because we did this together in the single responsibility principle. Now, we kind of already did that with the Apex stuff too, but in JavaScript, it's a very similar setup, but like we've talked about previously in this tutorial series, there is no concept of interfaces or types in JavaScript. So you can't create an interface and bound things to the interface. It's all a little more loosey-goosey. So, you know, we have a similar setup here where we have this opt service, and in this in this opportunity service Lightning Web Component, we want to be able to break out the logic based on different user types, right? So we've got this Lightning Web Component controller that has a calculate ops method that gets called, and we pass in the user type to that calculate ops method. And what happens next is we basically have concrete implementation JavaScript modules, which you can see here. This is the concrete implementation, which I realize is extremely small and basically nothing. And we have another concrete implementation here for Ops Service Manager. And based on if the user, what user type we have sent in, we initialize, one of those JavaScript modules or classes, however you want to view them. And we send those to this ops service factory, right? Again, factory pattern, important. So in this op service factory, we pass in this class type to the constructor, much like we did with the map. It's a little different, obviously, but it's similar to the map. Then we have this calculate ops method that we can call in here. And within the ops service here, we can just call calculate ops. And in this way, we're never really depending on a specific module, right? We still have to, unfortunately, at least the best way I've found in JavaScript, personally, we still have to implement, initialize them as classes here. But we can still kind of abstract that away and use dependency inversion here by creating this factory and calling the calculate ops method on this factory, as opposed to, having to say, having to actually call it on the concrete implementation itself, right? So this does that same abstraction for you. But it's a little bit different because, again, there's no interfaces, there's no typing, unless you use TypeScript, which doesn't particularly work well, unfortunately, with Salesforce. Someday maybe it will, but not so much today. Maybe with Salesforce functions, but that's a whole different ball game, right? So, all right, hopefully that makes sense. I'll put this example of the JavaScript dependency inversion principle, and I'll put all of I've just realized that I have not put any of this stuff up on GitHub, so sorry about that, but I'll put all of this stuff up for each individual lesson up on GitHub in a GitHub repo, and you guys can check out all of this code and use it as an example to kind of get an idea of where to start anyway when you're attempting to implement these different principles in your org, if you want to. All right, guys. I think that'll do it for this tutorial series. It's been a fun time and a long and challenging time making them, but hopefully they're very helpful and help you make some pretty cool things, save a bunch of time, and maybe a bunch of money if you're a business guy, and most importantly, create some really cool code. All right, guys, that's it for this episode. If you liked the video, please make sure to actually like it. Helps me a ton. Make sure to subscribe, hit the bell button if you want to know when the actual, video uploads happen, the moment that they happen. And if you really like the videos, become a supporter. Hit the join button on the video, and you get lots of cool things with it. It's like silly emojis of my, wonderfully weird face. And, extra voting privileges and stuff along those lines. So definitely check it out. That is it. Thank you so much for watching, and I will see you next time.